Alright, hi everyone. This is your bonus geekery content. This is not part of section 5.2 for this course, so this is optional. If you want to go on and take Math 1046 with us here at the college or any other like pre-calculus type course, you should really consider checking out this video and trying some of these problems. Okay, so this is optional. It's just for fun, but I do want to mention some of this stuff. So first thing I want to talk on, really the only thing for this section, is adding and subtracting square roots. Okay, so basically if we can add or subtract square roots in the same way that we can add or subtract like terms. All right, so if we think about x cubed and we're going to add that to x cubed, well, we can do that, right? There's a coefficient of 1 in each of these, although we never write it, and we could say, well, this would be 2x cubed. 1 plus 1 is 2x cubed. We add the coefficients, and because we have the same variable with the same exponent, we just bring that along. The same idea applies to square roots. These are called like radicals or like roots. Let's take a look at our example here. We have 7 root 11 plus 6 root 11. Again, we have the same root here, so we can apply the same ideas we do when combining like terms. What we do is we simply add the coefficients, 7 plus 6, and that gives us 13, and then we just bring along that like root. So 7 root 11 plus 6 root 11, we can add them up and call that 13 root 11. Okay, a couple more problems here. I get you to pause the video, give them a try. Fair warning. All right, so now let's take a look at the first one. I'll call this number 1. We have the same root, root 5. So basically this is going to equal 10 minus 2. Right? We could think of that in brackets and bring along the root 5 if we want to. 10 minus 2 is 8, and there's our root 5. Let's check out our second example now. Again, pause the video if you want. This is a good one. We have 1 root 3 plus 6 root 3, so that's cool. We can hammer that out. I know that's going to be 7 root 3. Right? But take a look at this negative root 12. We can actually reduce this guy a little bit. And what I mean by reducing, let me write it over here. We have root 12. We can take this number and let's factor it down into 2 factors. One factor has to be the biggest perfect square that we can get. Remember, our perfect squares are 1, 4, 9, 16, 25. Those are the first 5, right? Because this would be 1 times 1, this would be 2 times 2, 3 times 3, 4 times 4, and 5 times 5. So is there a way that we can break 12 down into one of these numbers? That's what I'm looking for. And there is. 12 breaks down into 4 times 3, right? 4 times 3 is 12, where 4 is one of my big perfect squares. That's the largest perfect square I can get out of this. So I'm going to rewrite this as the square root of 4 times the square root of 3. Okay? Sorry for that pen spike there. So the square root of 4, I know what that is. That's a perfect square, and that's 2. So 2 times root 3, or I could just express it as 2 root 3. Right? So what I've done now is I've simplified this root 12. So let's bring this back over into our problem now. I had 7 root 3 already, minus 2 root 3. Okay? Now, we can still take this a little bit further. 7 minus 2 is going to be 5. And because they're like roots, again, I just bring on the root 3. Okay? So lots of math geekery stuff there. I'll post a link on how to reduce roots as well if that's kind of new to you. And we'll geek out about it in our next class anyway. Again, all of this is optional. Don't feel that you have to do it right now for this course, but it will benefit you as well as we go on. Let's try one more kind of crazy example, and I'll give you a chance just to pause the video right now. Work it out on paper and see if you can do it. Okay, let's break this down. Let's take a look at these roots. I have root 7x, and I can't really break this down at all, right? 1 times 7, that's it. 2x, can't really do much with that either, unfortunately. 98, let's think about 98. Let's think about 28. Again, we're looking for perfect squares here, right? So, let me rewrite this. We got negative 5, 4 times 7. So root 4 times root 7x. I'll just leave the 7x all in 1 because I know I have the 7x over here anyway. All right? So I can break this guy down. That's cool. 98 Let me see, what are all the factors of 98? And I have no calculator whatsoever, so let's do a prime factorization on this guy. Let's do it by 2. So 2 times 54 would give me 98. None of those are really a perfect square. Let's do 2 times, oh, I don't know, 27. That's cool. 27 would be what? 3 times 9. 9's a perfect square. So that's cool. So let's go with 9 times, what's that? 2 times 2 is 4. 4 times 3 would be 12. So 9 times 12 will give me 98. I wonder if there's a bigger way. Could I do 16? Well, if we did 3 times 3, not really. So let's do 9 times 12 with this guy here. I'll rewrite him. So square root of 9 times the square root of 12x. Okay, again, I'm just rewriting just this guy out here. Well, 12 I could break down even further. 12 breaks down into 4 times 3x. All right, so 9 is not my biggest perfect square here. Let's just multiply both those together and I'll get the square root of 36. Let me get my pen tool here. This is live, by the way, guys. I have no idea what the answer is. I'm not just reading from a textbook. Well, maybe I should be. Okay, so let's rewrite this. After I clean this up. Make some room for myself. Okay. Get my pen back. All right, so we have root 7x plus, now this is going to be 36, right? 36 times 2x. So that's going to be plus the square root of 36 times the square root of 2x. That's this guy right here. Minus root 2x. That's this guy right here. Minus this, 5 square root of 4 times 7x. So now I've broken all of this down. Let's do what we can and factor out what we can. Square root of 36 is 6. So that's cool. Square root of 4 is 2. So 5 times negative 2, we'll evaluate that, and I'll write my next line. So we now have the square root of 7x, just rewriting this guy, okay, plus 6 root 2x minus root 2x minus 10, because 5 times 2 is 10, root 7x. Yay! This is a 1. This is a 1. Now let's combine some like terms. I have 1 root 7x minus 10 root 7x. So that's going to be minus 9 root 7x. And then I have 6 root 2x minus 1 root 2x. And that's going to be plus 5 root 2x. Awesome. Okay, so again, if you can do this before you get into college math 1046, you're going to be well ahead of everyone else. We're going to come back to this material as well in college math, but again, we go over it a lot faster. So it might be better for you just to take some time now. And again, I'll post a bunch of resources in the D2L site for us, and just start going through this because it's to your benefit for sure. Okay, so thanks for the Geek Out. I'll see you next time.